So now look at this question. Write the dimension of A over B in the relation. Okay, so this is the relation. They made us to know that P stands for pressure, S stands for distance, then T stands for time. Now, any quantity can either be a fundamental quantity or it can be a derived quantity. So every physical quantity can either be fundamental, it can be a fundamental quantity, or it can be a derived quantity. So if you're not a fundamental, it means you're a derived. Fundamental quantities are those quantities that doesn't depend on any other quantities for their SI units, while derived quantity are those that depend on other ones for their SI units. Like if you check now, what is the dimension for mass? Kg. It doesn't depend on anything. What is the dimension for length? Meter. You understand? That is m. That is the SI unit is meter. The SI unit for mass is kilogram. You understand? So it doesn't depend on anything. But if you check something like velocity, meter per seconds, you find out that it depends on length and time. So we have 7 main fundamental quantities, which is abbreviated as Tel, Emeka, and Messi, that love leads. So this stands for time, this stands for electric current, this stands for amount of a substance, this stands for mass, this stands for temperature, this stands for length, this stands for luminous intensity. So the SI unit for time is seconds, the SI unit for electric current is ampere, the SI unit for amount of a substance is mole, the SI unit for mass is kilogram, the SI unit for temperature is Kelvin, the SI unit for length is meters, and the SI unit for luminous intensity is candela. So that's the SI unit. So now we have 3 main fundamental quantities, okay? 3 main fundamental, which is time, length, and mass. So the SI unit for time is seconds, the SI unit for length is meters, and the SI unit for mass is kilogram. So now the dimension for time is T. Remember, the spelling for time stands for T, starts from T. The dimension for length is L, and the dimension for mass is M. So we call this the 3 main fundamental quantities because every other thing depends solely on the 3. Okay, so look at this now. They say write the dimension of A over B in the relation. So P is equal to A minus T squared over BX. Okay, P is equal to A minus T squared over BX. And they made us to know that P stands for what? Pressure. So I can still break this thing apart. I can still write that P is equal to A over BX minus T squared over BX. Such a way that if I still find LCM, it will still give me BS. I can still take the 2 up. Like if I have A plus C over E, I can break it apart as A over E plus C over E. So I can break them apart. Now, if pressure is equal to this minus this, it means that this will be the initial or final pressure, So final minus initial. So the SI unit of this is the same thing as the SI unit of this, and it's the same thing as SI unit of this. Imagine I told you that I have a speed of 3 meters, or I walk from a distance of 3 meters to 5 meters. I say, what is the distance I covered? So if final is 5 meters and the initial is 3 meters, you find out that total the distance I covered now will be what? 5 meters minus what? 3 meters. So, and the dimension or the SI unit for distance is also what? In meters. So you see, this is in meter, this is in meter. So it means that whatever thing that is here, the unit of whatever thing that is here is the same unit of whatever thing that is here, and the same unit of whatever thing that is here. So the unit of this is the same unit of this, and it's the same unit of this. So with that being said, now let us now find the dimension of what? Pressure. If you can be able to find the dimension of pressure, we now relate it to the dimension of this, or we now relate it to the dimension of this. So but we are going to work with only this because they say A over B. So this one contains A over B. So what is the formula for pressure? Pressure is given as force over what? Area. So when we talk about force, what is force? Mass times what? Acceleration over what? Area. So pressure means force over area. It also means mass times acceleration over area, because force means mass times acceleration. So what is the SI unit for mass? Kg. times what is the SI unit for acceleration, meter per second squared, over what is the SI unit for area. So the SI unit for area is meter squared. So SI unit for area is meter squared because it's length times length, and SI unit for volume is meter cube. So take note of these things. So now let us convert it to dimension. What is the dimension for mass? Capital M. What is the dimension for length? L, which is measured in meters. What is the dimension for time? That is seconds, which is t to the power of 2 over. What is the dimension for length? L to the power of 2. Such a way that if we resolve this, I can make this over 1, such that this will now be something over something, something over something. ml over t squared when I multiply this over L squared over 1. So if I should revert this, I'll have ml over t squared times 1 over L squared. So by the laws of indices, so this is t, this is L and L. The L power of this L here is 1. So I have ml to 1. When this L with the power goes up minus 2, then I have t. So this t is going up. There is no t up. Okay, so this is t raised to power what? Minus 2 because it's going up. So it carries a negative. So this is equal to ml to negative 1, t to negative 2. So this is the dimension for pressure. So it means that this dimension for pressure is equivalent to the dimension of this and equivalent to the dimension of this. So it means that the dimension of pressure is equivalent to the dimension of A over Bs, and also it is equivalent to the dimension of T squared over Bx. So now it means that ml to negative 1, T to negative 2 is equal to the dimension of A over Bx. Now remember that S, they say that S stands for what? Distance. And you know that distance is measured in what? In meters. Okay, and since distance is measured in meters, which is the SI unit, the dimension for meters is what? Capital L. So it means that this is ml to negative 1, T to negative 2 is equal to A over B times 1 over X. You know, A over Bx, I can split it to A over B times 1 over X, such that A times 1 is A, B times S is Bx. So I now have that ml to negative 1, T to negative 2 will now be equal to A over B times 1 over, what is the dimension for distance? Dimension for distance is what? L. So this is ml to negative 1, T to negative 2 is equal to A over B. And 1 over L means L raised to power minus 1. So as you can see, L raised to power minus 1 in both sides can cancel. So the dimension of A over B will now be equal to mt to negative 2. So this is the dimension of A over B. So don't forget, this is very, very significant. Anything you ask to get the dimension, that's the easiest way to get it. What is the dimension for force, mass times acceleration? What is mass you put, what is acceleration you put? You compute it, you get what you want. So as simple as that.